Circular motion 1. Introduction. If you are going round circles, then you are getting nowhere. However, going round in circles is very important in physics. Knowing how galaxies rotate, whether you are really going to make it round the loop on a roller coaster, and how electrons move in magnetic fields all depend on knowing how circular motion works. In this first lesson on circular motion, you will look at the speed and velocity of things moving in circles, meet a new way of measuring angles. In this activity, you will examine the difference between speed and velocity. Click play to make the train run. You can click reverse button to start again at any time.
So please observe that when the train is moving with a constant speed, the velocity actually is always changed. The velocity change because how is it? You see, because velocity and the speed, the difference is the magnitude and the direction. The magnitude and the of the velocity and the speed are equal, but for the direction, velocity consists with the direction, right? So this means that the direction always change, but the magnitude, you see, the size of the arrow always constant. This means that it's always constant speed.
You will see there is a graph showing the speed and an arrow which shows the velocity. Why don't you need an arrow for speed? Answer. Speed is a scalar quantity. It has magnitude, size, but no direction. Why do you need an arrow for velocity? Answer. Velocity is a vector quantity. It has magnitude and direction. What do you notice about the length of the velocity arrow changes as the speed changes? Answer. This is the same because the speed is the magnitude of the velocity. Click pause button to freeze the motion and look at the speed and velocity. From the drop-down menu, select drop-down button. Select the correct description of the motion. The train will start moving when you get the correct answer.
So we choose constant speed and changing velocity. It's moved with constant speed but changing of the velocity. This means that velocity, the direction change.
There is one of the descriptions which can never happen. Which is it? Answer. Changing speed and constant velocity.
Okay, so this means that we need to, just now we just can choose one only, right? Let me see, I can choose another one or not. Okay, cannot.
See if you can pause the train at a place which fits each of the other three descriptions. Selecting Go Back to Station button gives you a way to vary the motion of the train.
Okay, so just now it's constant speed as constant velocity, right? Now we choose that constant speed but changing velocity. So this means that, okay, I don't want to go back to the station. but cannot, I must go back, is it? Okay, so don't want to go back. Okay, if don't want to go back, cannot choose. Why like that? Go back to station, give your way a very motion to the, okay, let's go.
You have seen that an object can have a constant speed but a changing velocity. When does this situation occur?
Okay, so you can see that an object can have a constant speed. That means it moves in a constant speed, but changing velocity. That means that the direction can be changed. Okay, or the, okay, mostly velocity change because of the direction. So when does this happen?
Answer: when the object is changing only its direction of travel or moving in a circle with constant speed.
You see, as we know that the object is changing when there is a change. Okay, speed constant, velocity can be changed. That means that the magnitude of the velocity and the speed are equal, but the direction of velocity change.
The diagram now has two trains. Click play button to start them going.
Both of them move with the same speed, but you see that the magnitude, the size of the arrow are equal, but the direction of them are different.
Click pause button at any time and select the right description relating to the motion of the two trains.
Okay, relate. Okay, so these two, okay, how to choose? Okay, select the right description. Where is the description I can choose? Okay, I can't choose any description. Okay, never mind. Let's go on. This means that now both of them are moved with the same magnitude, same speed. Okay, but the velocity 1 and velocity 2 are with the same magnitude but different direction. Okay.
There is one description which can never happen. Which is it?
Okay, so there is one description which can never happen. So same speed and different velocity already happened. Same speed and same velocity. Is it same velocity? Okay, so different speed with same velocity or different speed and different velocity. Different speed and different velocity. If difference, that means that it can be same speed. Okay, it can be same speed but different velocity. This one correct. Different speed and same velocity. Same velocity. Okay, different speed can be same velocity. Is it possible? Okay, so that means that no.
Different speed and same velocity.
Okay, if different speed, that means different velocity. Impossible different speed with the same velocity. Okay.
Try to pause the motion at places where each of the other three descriptions are correct. Again, you might find go back to station button helpful.
Okay, we cannot move.
Remember, you can click reverse button to start again at any time.
Okay, if we start, this means that we can move it at any time. Okay, but we need to pause and you will see that choose any one. Okay, cannot not. Okay, no, cannot. So maybe there is some of the problem of the software.
What
okay,
do you
let's go.
notice about the direction of the velocity arrow and the curve the train is traveling on?
So when they are moving, okay, at any constant, at any instant, okay, what do you notice about the direction and the velocity arrow? Okay, So direction, difference, difference position, difference location, difference direction.
Answer. The velocity arrow is always at a tangent to the curve where the train is.
Okay, so that means that the velocity, you look at the, okay, what is that trend? Trend one, right? The velocity, same direction. What is meant by tangent? That means that 90° to the, okay, to the circle. 90° to the circle. This is the center, right? Okay, always point to the center. This direction will be 90° to the circle. This one, 90° to the circle. So we can notice that how is the 90°? That means that from here, this is the circle, right? So that means that this is 90°. For this trend, this will be the 90°. Okay, so the 90° here. Okay, so this means that always show that tangent.
Click play to start the train moving.
When the train is
Describe
moving
its
again,
motion in terms of its speed from the beginning.
so this means that we notice that the speed are constant. Okay, so we notice that the speed of the train are move in a constant speed, but the velocity always change. The velocity change direction, but not change the magnitude.
Answer. It increases speed steadily, then travels at constant speed. Describe its motion in terms of its velocity from the beginning. Answer. The magnitude of the velocity increases steadily, then remains constant. The direction of the velocity changes continuously. Click pause button and use the slider to set different speeds and click play to see what happens. Describe the motion of the train in terms of its acceleration.
Okay, now I increase a bit the speed. Okay, then see what happened. The size become bigger, right? That's now the graph. Okay, the speed show that speed increase until with higher speed at a constant higher speed.
Answer. At the start, there is an acceleration which causes an increase in speed. When the train has reached its maximum speed, there is still an acceleration because it is changing direction. What must be present to cause an acceleration? Answer. A force. There are several forces which would act on its train, but three forces which control the motion you have been investigating. 1. Driving force of the engine. What does it do?
So what is force? Force is, okay, a push or a pull, yeah? Okay.
Answer. Causes the increase in speed.
So force is used to increase the speed of the train.
What is its direction? Answer. In the direction of travel at a tangent to the curve.
So the direction always change. What is the direction? That means that the direction, okay, at any tangent. Okay, where is it? That means the tangent will be the direction.
2. Friction. What does it do? Answer. Acts against the driving force and will increase until it balances the driving force and constant speed results. What is its direction? Answer. Against the direction of travel at a tangent to the curve.
Okay, so this means that if the action is moved forward, the friction will be the reaction. That means that what's that? The friction is always against the motion, against the action. So that means that it will be in opposite direction.
3. Sideways force of the rails on the wheels. What does it do? Answer. Provides the force that keeps the train moving in a circle. What is its direction? Answer. Towards the center of the circle.
So this means that when the train is moving in circular motion, okay, there will be a force. There will be a force always point to the center, okay, 90 degree. So this is the another force. This is a new force we learn in, okay, in the circular motion, okay.
The force needed to keep something moving in a circle is called the centripetal force. Uniform circular motion is when the only resultant force on an object is the centripetal force. Describe the motion you would get.
So this means that when any object moves in the circular motion in circle, always there will be a force point to the center. If the object reach here, that means this go to the center. If the object here, so it will be always, no matter where is the position, where is the object, there will be a force always point to the center. So we call that all of these are the centripetal force, 90 degree to the object, yeah. So against this, all we call that is a centripetal force.
Answer. Moving in a circle at constant speed. What is true about the directions of the centripetal force and the velocity? Answer. They are perpendicular.
They are perpendicular. That means that if the V, if this is the V, let's say I use, okay, V, I use blue color. If this is the V, okay, let's say this is our V. Okay, sorry, if this is the V, that means that we will have a force. The centripetal force to the center, okay, there will be the F, capital F. Okay, so this means that what is the relationship between F and V? F and V are always in perpendicular motion, 90 degree. Okay.
Summary. Uniform circular motion is motion in a circle at constant speed. Speed is a scalar quantity. Velocity is a vector quantity and is not constant during uniform circular motion as the direction of travel is continuously changing. The direction of the velocity is at a tangent to the circle being traveled. The speed is the magnitude of the velocity. There is an acceleration as the velocity is changing. This acceleration is provided by a force directed to the center of the circle. This force is known as the centripetal force. Uniform circular motion occurs when the resultant force on an object is perpendicular to the direction of travel. Select a value from the drop-down menu button to set a radius for your circle and click Draw to produce the circle you have chosen.
So here I can choose okay, let's say if 1, how is it? 5, how is 1, 2, 3, 4, 5? So that means that, let's say I start with 1. Okay, so that means that once it's moving, okay, okay, 1 is moving. Okay, you see the red color 1 turns. That means that, okay, let's say distance move 6.21. Okay, 1 turns is equal to how much? Around, okay, 360. So that means if 359 is 6.26 cm, right? Okay, let's say I record. For 2 cm, let's say, if 2 cm, that means that I still move with 359. So now notice that the distance increase. Distance, that means that the distance travel. Okay, if 3 cm again, let's draw with 359 degree. Because if 360, that's in back to 0 already. So let's say I choose 359. Notice that same angle but distance difference. If I choose 4 cm, the radius, so how is the 359? So that means that it moved 25.06 cm. Okay, so if for 5 cm, so let's see what happened. The distance increase. Okay, so that means that for 1, 2, 3, 4, 5 cm, so we notice that what happened is, okay, so this I draw twice already. Okay, I cannot do. So that means 1 cm, 2 cm, 3 cm, 4 cm, 5 cm of radius. Different radius, but move with the same angle. So that means that the distance travel. The distance travel will be the circumference of the circle will be different as well.
Click and drag the insect around the circle.
Okay, this one done. Done, record, select another, done.
What do you notice about the recorded results?
What do you notice about the recorded result?
Answer: the angle is always the same.
Same angle, right?
This angle is called the radian, rad, and is the angle subtended at the center of a circle by an arch on the circumference equal to the radius in length. It is the SI unit of angle.
So radian is the SI unit for the angle, yeah, radian, not the degree, yeah.
How many radians equal 360 degrees? Or how many radii equal the circumference?
So one circle, how many? So there is 2 pi.
2 pi. For an angle theta rad, what is the length of its arc in terms of the radius r? Answer: theta r.
So theta r, this means that there will be the distance travel. For example, from 0 degree to certain degree. So this means that the distance traveled by the ladybug, will be the radius times with the angle in radian.
Radians are used in circular motion equations involving the angular velocity, omega, which is the number of radians traveled per second. The period of a rotation, t, is the time to complete one rotation. How many radians is one rotation?
So what is meant by angular velocity? Angular velocity is the velocity when the object is traveling in the circle, in circular motion. So there is a rate of change of angular displacement. So now we look at here. When it's moving, move in one circle. That means that the circumference will be the angular displacement. The displacement in circle. Angular velocity will be the velocity in the circular motion in this direction. Just now we learned that if the the speed or the velocity will be in this direction, right? That is the linear velocity or linear speed. But circular motion is always follow the circle.
Answer 2, 5.
One complete circle with 360 degree, that means with 2 pi radian.
Give a formula for omega in terms of 2 pi and t.
So the angular velocity, we use the the symbol of look like W, but it's named as omega. Okay, omega equal to V equal, as we know that the V is equal to S over T, right? What is the displacement? It's 2 pi over T.
Answer, omega equals 2 pi divided by t.
This one is in circular motion. If in linear motion, V equal to the distance of one circle, that is one circumference, 2 pi over T.
Now
Okay.
it's time to test your knowledge of radians and angle with a snap game.
So this one, game, no need. Okay, they just want us to convert
radians and angle in degrees, or a picture of a circle showing an angle.
So this means that they just want us to convert it into the, match either the, the unit, the angle in degree match with the angle in the radian. Okay, so this one, no need. Okay.
When both cards, summary, the SI, System International de Unités, unit of angle is the radian, rad. 1 radian is about 57 degrees and is the angle subtended at the center of a circle by an arc on the circumference equal in length to the radius. For an arc on the circumference which subtends an angle theta measured in radians, the length of the arc equals r theta. The angular velocity omega is the rate of change of angular displacement and is given by omega equals 2 pi over t, where t is the period of the rotation.
Okay, so that means that this will be the all of the summary, all of the conclusion. Okay, for this lesson.